Hello guys, I welcome you all to Achieve channel. We have started this channel especially for civil engineering students and aspirants. First we'll start with GATE PYQ series because in the next 3 months your GATE exam will be upcoming. The first subject will start with soil mechanics as it holds 13 to 15 marks in every year GATE. Also it's easy to learn and crack if you are well versed with formulas and concepts. You can pause the video to read questions because I'll start with given data and proceed to solve. Our question has been posted in Instagram page and YouTube shorts daily before answer gets uploaded in our YouTube. So let's begin. In this question, first we'll write down the given data. Given. So it is given that E max equal to 0.85, E minimum, which is maximum void ratio and minimum void ratio equal to zero point 0.5. The soil is compacted to a mass density. Mass density or bulk density, you call it as anything. It is 1800 kilogram per meter cube. And water content as 8 percentage, which will be equal to 0.08. And they also have has given take the mass density of water, which is equal to 1000 kilogram per meter cube. And G, specific gravity of soils, is equal to 2.7. Now they are asking us the relative density of soil. So we'll start deriving the solution. First of all, relative density. The formula for relative density, which is equal to E max minus E, which is natural void ratio, divided by E max minus E minimum into 100, which is expressed in percentage. So we have E max and E minimum, but we don't have E. So to find out, we will be solving some more steps. Now we have bulk density, which is 1800 kilogram per meter cube. With that, we'll find out this dry density of the same soil. D is equal to sigma by 1 plus W, which is sigma is equal to 1800 divided by 1 plus 0.08, where you will be getting dry density. We'll calculate the dry density. 1800 divided by 1.08, which is 1666.67 kilogram per meter cube. From dry density, we can find out which is gamma d is equal to, sigma d is equal to G sigma W by 1 plus E. If it has been given by unit weight, you should write it as gamma d is equal to G gamma W by 1 plus E. It is a functional relation equation. So 2.7 into 1000 divided by 1 plus E, which is equal to 6.67. So from this, E will be equal to 2700 divided by 16667 minus 1, which will be equal to 2700 divided by 1666.67 minus 1. That is 0.6199. We will take it as E is equal to 0.62. So 0.62 is the unit weight of soil when the dry density or else when the mass density of the soil is 1800 kilogram per meter cube. Now from this we'll take ID is equal to, sorry, ID is equal to Emax. Emax it has been given by 0.85, E minimum 0.5. 0.85 minus E, which is equal to 0.62 divided by 0.85 minus 0.5 into 100. 0.85 minus 0.62 divided by 0.85 minus 0.5 into 100, which will be equal to 65.714 percentage. Guys, start using gate calculator right from now, because since you have only 3 months, practicing from now is most important, because at the examination hall you might be very good with your normal calculator, but since gate exam consists of calculator embedded in systems, at the time you will struggle, so start using from now. In this question they are asking us to find out the degree of saturation of the soil. So we'll be writing the given data, which is specific gravity of soil, it is 2.71, and they have also given the porosity, which is 40 percentage or zero point 0.4, and they have also given the water content, which is 20 percentage or 0.2. And now they are asking us the degree of saturation. So, solution. We all know that the functional relationship and the equation which is given as SC is equal to WG. You can remember this equation as Sevag equation. So we want to find out the degree of saturation. We have the water content, we have specific gravity. We don't have this void ratio. So void ratio can be calculated from E is equal to N by 1 minus N, which is 0.4 divided by 1 minus 0.4, which will be equal to 0.67 is our void ratio. So from this we can easily calculate S. S will be equal to Wg by E, which is equal to zero point 0.2 into 2.71 divided by 0.67. 0.2 into 2.71 divided by 0.67, which is 0.808 or 0.81 will be our degree of saturation. And they have asked the saturation in percentage, and then it will be like 81 percentage. Observe this question carefully. They have given all the data as indirect. First point, soil behaves fluid like when water content is more than 40 percentage, which means soil will be like a fluid when the water content is more than 40 percentage. Defines that liquid limit of the soil as 40 percentage. And soil behaves semi-solid when water content is more between 15 percentage to 80 percentage, 28 percentage. So it defines the Soil will be plastic. Semi-solid means plastic, okay? So soil will be plastic when the water content is between 15% and 28%. So the plastic limit of the soil will be 28 percentage. About 28 percentage soil will not behave as plastic. And they have also given fine grain soil consists 60 percentage silt content, which means that soil say composition of silt and clay, where 100% of soil will be equal to 60% of silt and remaining will be clay. Therefore, clay percentage will be equal to 40 percentage. So these are the given data which has been found by us. They have given indirectly. So now they have asked us to find out the activity of the soil. Since we have liquid limit and plastic limit, we can find out the plasticity index IP, which will be equal to liquid limit minus plastic limit, which is 40 minus 28 equal to 12. And activity A will be equal to plasticity index by C, which is percentage of clay lesser than 2 microns. So which will be equal to 40, oops, sorry, which will be equal to 12 by 40, which is zero point 0.3 is the activity of clay. And option C is the right answer. So in this question, it has been given that the volume of the embankment is 5000 meter cube. So we'll be writing where it will come. Okay, given volume of embankment equal to 5000 meter cube. Target dry unit weight. Just dry unit weight of the soil sample is 16.2 kilonewton per meter cube. Target dry unit weight means the unit weight you need to maintain for the embankment, that is 16.2 kilonewton per meter cube. And void ratios of each of the site has been given, site X, site Y and site Z, and the distance also has been given from the construction site. So what we will be doing, we will be removing soil from one site and we will be placing it in the construction site. So among these three sites, which site is cheaper? They are asking in this question. Okay. Next, they have also given the specific gravity of the soil. So specific gravity of the soil G is equal to 2.7. And last, this cost parameter will come at last. So right now we will take these parameters and solve the question. So they have also given us unit weight of water. They have also given unit weight of water as 10 kilonewton per meter cube. Right. So we'll go to the solution now. So from the functional relationship, we know that gamma D is equal to G gamma W by 1 plus E. So from this, we can find out the E, which is equal to target void ratio. So we can find out the target void ratio. So gamma D, which is equal to 16.2 is equal to 2.7 into 10 divided by 1 plus E. From this we will be getting ES. We will calculate what is E. Okay. 27 divided by 16 minus 1. So we'll be getting ES 0.6875 is the target void ratio. Now, if you see this functional relationship, that is volume of solids for all sides will be same. Sorry. So V will be equal to volume of voids plus volume of solids. So V is equal to EVS plus Vs, whereas E is equal to volume of voids with respect to volume of solids. So from this, V is equal to Vs into 1 plus E, which will be given by Vs is equal to V by 1 plus E. So we'll be finding out the volume of solids for site X, site Y, and site Z with respect to 5000. Like we'll be comparing the volume, both the volume. Means if you see volume of solids for site X and site Y are equal, then Vx by 1 plus E will be equal to you have to compare with the construction site, because there only you are going to find out the there will be there you are having the target unit volume and target void ratio. Okay, so it is will equal to V by 1 plus E. So we will be making it as 1 plus EX. So right now Vx, how much Vx it is, we'll see. We have to calculate the Vx, and Ex will be 0.6. So Vx by 1 plus 0.6 is equal to target volume, which is 5000 divided by 1 plus we'll be taking 0.6875 as 0.69, just an approximation, no issues with that. So with this we will be getting it as Vx is equal to, we'll calculate now, 5000 into 1.6 divided by 1.69. 4733.723 meter cube. Same for Vy by 1 plus Ey. What is Ey? Ey will be equal to zero point 0.7. Zero point 0.7, which is equal to 5000 divided by 1 plus 0.69. So Vy will be equal to just 5000 into 1.7 divided by 1.69. 5029.58 meter cube means that to make 5000 meter cube volume at the construction site, you need to remove 5029.5 meter cube from the site Y. Same for site Z, Vz by 1 plus. We'll see what is the void ratio for site Z. It is 0.64. 0.64, which is equal to 5000 divided by 1.69. So VZ is will be equal to 5000 into 1.64 divided by 1.69, which will be equal to 4852.071 meter cube. So this much amount of soil we need to remove from one side to make a target volume of 500 meter cube at the construction site. Now, going to the question, it is also given that the cost of transportation, see, the cost of transportation per kilometer is twice the cost of excavation per meter cube, which will be equal to cost of transportation equal to will be x. Assume cost of transportation is x, then cost of uh, excavation per meter cube, which is given by x by 2, or else we can take it as cost of transportation will be 2x and cost of excavation will be x. So it won't be any issue if you take like this. Now we will be calculating for site x, site x, which is cost of transportation. What is the distance from site x to construction site? It is 140 kilometer. So 140 into 2x plus what is the volume it needs to be excavated? It is 4733. You can neglect the points 4733x, which will be equal to 4733 plus 280, 5013x for site Y. What is the distance between site Y and construction site? It is 80 kilometers and volume 5029. So 80 into 2x plus 5029x be equal to 5029 plus 160, 5189x, and a same for site Z. Distance from site Z to construction site, it is 100 kilometer and the volume of excavation. So 100 into 2x plus volume of excavation, it is 4852x. Why I'm neglecting points here? It is because the excavated volumes are having a major difference. So you will definitely get um, a lot of difference in calculation. So it is you can also include the points and calculate, whereas you can leave the point. It won't be any issue. 200 plus 4852, which is 5052x. So in the above three, 5013x. Therefore, site x is the most economical. The answer will be A. In this equation, it is given that the water content of a fully saturated soil mass. So we'll be writing the given fully saturated soil mass means degree of saturation, which will be equal to 100 percentage or 1. See here, water content of a fully saturated soil mass is 100 percentage. So water content will be equal to 100 percentage or 1. And they have asked us to find out the void ratio. We have to find out the void ratio. Solution. From the functional relationship equation, which is SE equal to WG, you can easily remember this equation as Sevag equation. So it is given that S will be equal to 1 into E, which is equal to W is 1 into G. So we'll be getting E equal to G. And from the given option, option B is the right answer.